Hey there, welcome to the solutions video for section 3.5 homework. Going to turn to page 193. We're going to do 11 through 23 odd, 35 through 51 odd, and number 67. So we're just taking the limit here. I'm also going to state where there's a horizontal asymptote, if there is one. So we're just worried here about the highest power. So really all we care about, we don't care about the 1 or the 2. It's really just 2x over 3x. And the x's will cancel. Remember, when there's a tie on the highest powers, you use the coefficients. So the answer to this question is 2/3. So we have a horizontal asymptote at y equals 2/3 on this graph. All right, for this one, the bottom wins. So we have a higher power on the bottom. So when you have the higher power on the bottom, the limit as x approaches infinity is 0, because it's like infinity over infinity squared, which is much larger than infinity, so it goes to 0. So we have a horizontal asymptote at y equals 0, which is just the x-axis. All right, for number 15, the top wins. The higher power is on top. Not worried about the 3, just the x's. And so when that happens, the answer does not exist. So the limit does not exist. So we have no horizontal asymptote. All right, for number 17, we have a tie here, but we have negative infinity. We're approaching negative infinity. Now, I don't really worry about the negative when there's not a radical involved, like with number 15. But I do worry about it when there is a radical. So this is like x over the negative square root of x squared. So the square root of x squared is x, so that's like x over negative x. So that's -1. So we have a horizontal asymptote at y equals -1. All right, number 19, it's just approaching infinity. So we're just worried about the higher powers, like 2x on top and the square root of x squared. So that's like 2x over x. And so it's a tie. So tie goes to the coefficients. So our coefficient 2 over 1, that's 2. So we have a horizontal asymptote at y equals 2. Then number 21, sine of anything, sine of any angle just oscillates between -1 to 1. Well, that means the bottom wins, doesn't it? Bottom wins. So that's like a 1 over infinity, so the answer is 0. So we have a horizontal asymptote at y equals 0. Okay, let's take a look at 23. We have the limit as x approaches infinity of 1 over 2x plus sine x. All right, sine x just oscillates between 1 and -1, right? So it's really not a part. Just kind of cross that out. It's really the same as 1 over 2x. Because that just doesn't move the meter. All right, so the bottom wins. highest power is on the bottom. So when that happens, you plug in infinity. It's like 1 over 2 times infinity, so it's 0. So we have a horizontal asymptote at y equals 0. All right, let's flip over to the next section. This time we're trying to find both the horizontal and the vertical asymptote. So 35, we have y is equal to 2 plus x over 1 minus x. Well, let's find the vertical asymptote first. It's just about the denominator, right? So we have the denominator equals 0 when x is 1. So we have a vertical asymptote at x equals 1. Now for the horizontal asymptote, you know, you can go through the limit process, but we can just eyeball this. The highest power for the horizontal asymptote, we have x over negative x, right? X over negative x. So we have a horizontal asymptote at y is equal to negative 1. So we have a tie here. So the coefficients are 1 over negative 1, so we would have y equals negative 1. All right, so unless it says take the limit, you don't have to. You can just use your eyeballs, and we can determine the horizontal and vertical asymptotes. Now we might have to do some factoring. So here we have x over x squared minus 4. So this one, I'm going to just use my eyeballs to look and see where is the horizontal asymptote. The highest power is on the bottom. Okay, so when that happens, then you have a horizontal asymptote at y equals 0. The bottom wins. Now for the vertical asymptote, let's factor this. We'd have x over x plus 2 and x minus 2. So nothing cancels out here. So it's where the denominator is equal to 0. So we have vertical asymptotes at x is equal to plus or minus 2. Either of those numbers. Negative 2 would make this parenthesis 0. Positive 2 would make this parenthesis 0. So that's where we would have a vertical asymptote. All right, I'm going to take a risk and try to sneak this into the bottom. We have x squared over x squared plus 9. The bottom will never be 0 because anything you put in and square, it's going to be positive. The bottom is always positive. So when that's the case, we would have no vertical asymptote if the bottom never hits 0. However, we do have a horizontal asymptote, right? Because we have a tie, x squared over x squared. We use the coefficients, 1 over 1. So we have a horizontal asymptote here at y equals 1. Now don't put just 1, put y equals. All right, moving right along. Okay, pause the video if you need to catch up. Okay. Number 41. Okay, we have y is equal to 2x squared over x squared minus 4. Okay, first of all, let's just eyeball this and find the horizontal asymptote. We've got a tie with the highest powers. The coefficient here is 2. The coefficient here is 1. So we have a horizontal asymptote at y equals 2. Now, as far as finding a vertical asymptote, we'd have 2x squared, and we can factor the bottom into x plus 2 times x minus 2. Now, neither of those parentheses will cancel out. So both of the numbers that make the denominator 0 are vertical asymptotes. And once again, plus or minus 2. All right, 43. That one's a little tricky. We have xy squared is equal to 4. Well, we're going to have to solve this for y. So y squared is equal to 4 over x. And therefore, y is equal to plus or minus the square root of 4 over x. Okay, so what we have here is we don't really have to worry about it too much. Where's the denominator 0? Well, our vertical asymptote occurs at x equals 0. So that's pretty easy, and we can really eyeball both of these. The bottom wins, right? We have no variable on top, just a constant, and then an x on the bottom. The bottom wins. So that's how we determine the horizontal asymptote. So that's at y equals 0. So basically, both the x and y axis in this one are asymptotes. So that's pretty cool. We're moving along pretty good. So these are a lot less complicated than determining the min and the max and the increasing and decreasing intervals, all of that. So we have number 45. 45 is y equals 2x over 1 minus x. The vertical asymptote, very easy to determine. That occurs at x equals 1, because a 1 would make the denominator 0. The horizontal asymptote, okay, it's a tie, so I've got a 2 over a negative 1 in terms of the coefficients of the highest power, so that's at y equals negative 2. Okay, 47. We have y is equal to 2 minus 3 over x squared. Now this one's a little different, and we're going to actually need to look at taking the limit to find the horizontal asymptote. Can't really just eyeball it. The vertical asymptote is really easy, because what makes this function undefined, it's a z when you have 0 in for x, right? Because that'd be 3 over 0. That's undefined. So at x equals 0 is where the vertical asymptote is. But the horizontal asymptote, this is one where we need to take the limit as x approaches infinity of 2 minus 3 over x squared. So if you plug infinity for x squared, then that's the same as 2 minus 0, right? 2 minus 3 over infinity is 0. But you're left with the answer of 2. So we have a horizontal asymptote at y equals 2. So that one is just a little bit different. Remember, to find the horizontal asymptote, we're taking the limit, but on all of these up through number 45, we could really just eyeball it to determine where the horizontal asymptote was. Okay, we're moving along great. This one is just like 47, really, isn't it? 3 plus 2 over x. So what makes this undefined? All right, it's where x equals 0. So we have a vertical asymptote at x equals 0. And then to find the horizontal asymptote, we're going to take the limit as x approaches infinity of 3 plus 2 over x. All right, when you plug in infinity, 2 over infinity is just 0, isn't it? It approaches 0. So that's just going to be 3 plus 0, which is 3. So we have a horizontal asymptote at y equals 3. Okay, just one more, and then our word problem. So 51, we have y is equal to x cubed over the square root of x squared minus 4. Well, in this case, the top wins. So there is no horizontal asymptote. The limit as x approaches infinity does not exist. Now, looking at the bottom here, it's going to be x cubed over the square root of x plus 2 times x minus 2. All right, so in this particular case, we do have vertical asymptotes. These parentheses don't cancel out. So we have vertical asymptotes at x equals plus or minus 2. All right, so let's look at number 67. That one says a business has a cost of C is equal to 0.5x plus 500 for producing X units. The average cost per unit is C bar, remember the bar just means the mean or the average, is equal to C over X. Find the limit of C bar as X approaches infinity. So if C bar is equal to C over X, and we know that C is 0.5x plus 500 over X, if we divide X into each one of those, we know that C bar would be 0.5 plus 500 over X. Now, I'm not going to do 500x to the minus 1 because I don't have to take the derivative. We're taking the limit of C bar as X approaches infinity of 0.5 plus 500 over X. Well, 500 over infinity is just 0. 500 over an infinitely large number is an infinitely small number. So that's 0.5 plus 0, which is equal to 0.5. So all that means from a business standpoint is that if you make an infinite number of units, the minimum cost that you're going to have is 0.5. Okay, whatever that is. Half of a million, I don't know. This might be in millions or something like that if it's a large business. All right, so that is it for this video. I hope that helped if you had any struggles, and I'll talk to you next lecture.